Force. Force applied on a body is defined as the rate of change in its linear momentum. Force is a vector quantity and its SI unit is Newton. Moment of force. Translational motion, rotational motion. When a force applied on a stationary rigid body which is free to move, the body starts moving in a straight path in the direction of the force applied. Rotational motion. If a body is pivoted at a point and a force is applied on the body at a suitable point, it rotates the body about the axis passing through the pivoted point. This is the turning effect of the force, and the motion of the body is called the rotational motion. Torque. Factors affecting the turning of a body. The magnitude of the force applied, the perpendicular distance of line of action of force from the axis of rotation. Measurement of moment of force. The moment of force is equal to the product of the magnitude of the force and perpendicular distance of line of action of force from the axis of rotation. Moment of force is equals to force into perpendicular distance of force from point. SI unit of moment of force is Newton meter, short form Nm. 1 Newton meter is 10 to the power 5 dyne into 10 square centimeter, which is 10 to the power 7 dyne centimeter. 1 kgf into meter is 9.8 Newton meter. 1 gf into centimeter is 980 dyne centimeter. Clockwise and anti-clockwise movement. If the effect on a body is to turn it anti-clockwise, the moment of force is called anti-clockwise movement and it is taken positive. All you have to know in clockwise and anti-clockwise movement is its charge. Anti-clockwise movement is positive, clockwise movement is negative. Okay, if the effect on the body is to turn clockwise, the moment of force is called clockwise movement and it is taken negative. The moment of force is a vector quantity. On applying a force on a pivoted point, its direction of rotation depends not only on the direction of force applied, but also on the point of application of force. Direction of rotation of a body can be changed by two ways: by changing the point of application of force and by changing the direction of force. A single force alone does not cause rotation of a pivoted body. Actually, rotation is always produced by a pair of forces. For example, if you have to open a tap, you can't open it with one finger, right? You'll need to use at least two fingers to open it. So that's a pair. The moment of force of reaction about the pivot is zero because its distance from the axis of rotation is zero. When we rotate something, the distance is always zero because it always comes to its actual position, The pair of forces formed by the external force and the force of reaction is called a couple. Moment of couple. That diagram illustrates the effect produced by a couple. The perpendicular distance between the two forces A and B is taken d, which is called the couple arm. The two forces cannot produce translational motion as their resultant sum in any direction is zero. But each force is capable of producing a turning effect on a bar in the same direction. Thus, the two forces together form a couple which rotates the bar about the point O. Two forces rotate the bar in anti-clockwise movement. This is a formula based on which we will be doing numericals in the chapter force. Moment of force F at the end A will be F into OA. O is the pivoted point and A is one force. Another force is B. So next is moment of force F at end B is F into OP. Total amount of couple, that is amount of both forces, is F into OA plus F into OP. Let's take F as similar. F into OA plus OB is equals to F into AB. We took AB as D, so it will be F into D, anti-clockwise movement. Thus, moment of couple is equals to either force into perpendicular distance between two forces or couple arm. When a number of forces acting on a body produces no change in its state of rest nor of linear or translational motion, the body is said to be in the state of equilibrium. Kinds of equilibrium: static equilibrium, dynamic equilibrium. In static equilibrium, when a body remains in a state of rest under the influence of several forces, and dynamic equilibrium is when a body remains in the state of motion, translational or rotational. It can be both. Under the influence of several forces, the body is said to be in the form of dynamic equilibrium. Conditions of equilibrium: the resultant of all the forces acting on the body should be zero. The algebraic sum of moments of all the forces acting on the body about the point of rotation should be zero. Principle of moments. This is the last thing in force part 1. Principle of moments. According to the principle of moments of equilibrium, sum of anti-clockwise movement is equals to sum of clockwise moments. Based on these formulas also, we'll get few numerical questions, and for clearance I'll be making another video in which I'll be telling you all the important formulas for numericals. If you all want important parts in center of gravity also, then you all please go and watch in my channel only. There'll be another video uploaded.